Welcome to the lecture on problem solving on replacement analysis. So, in this lecture we will discuss about a problem which is based on replacement analysis, and we will see how we take the different study periods and how the problem is analyzed. So, let us see a problem where it is mentioned that the operation is carried out on a machine P with present salvage value as rupees 1 lakh and life of 5 years, after which it will have 0 salvage value. Operating cost on machine P is 60,000 rupees per year. Now, after 5 years, machine P will be replaced by machine Q with initial cost, life, final salvage value and annual operating cost as rupees 5 lakh, 15 years, 0 and rupees 30,000. So, basically for initial 5 years machine P will be used, and then it will be succeeded by machine Q which has all these details. Now, there is a proposal for replacement, and that is for machine R. So, this machine R, it has estimated initial cost of rupees 4 lakh, life of 15 years, final salvage value as 0 and operating cost as rupees 45,000 per year. So, basically you have a machine P which will work for 5 years, and after 5 years it will be replaced with machine Q. Then another option is you have now machine R with you. So, whether you should go for machine P plus Q or you should go only for machine R at present, and for that basically there are two considerations. One is that if you look at machine P, it has a life of 5 years and Q has 15 years. So, altogether you have 20 years. Now, in that case machine R, it has a life of 15 years. So, we can have the study period of 15 years. In that case machine Q will only be used for 10 years. So, its life of 5 years will be remaining. So, let us see how to solve this question. So, the data first of all we will write what is given. So, basically you have machine P, life 5 years, first cost as rupees 1 lakh, salvage value 0, and annual operating cost is 60,000. Plus you have after 5 years machine Q is coming. It has life of 15 years, first cost is given as rupees 5 lakh, salvage value again given as 0 and annual operating cost is given as rupees 30,000. Now, opposite to this you have a machine Q R. machine R, its life is 15 years, first cost is given as rupees 4 lakh, salvage value 0 and operating cost is 45,000 per year. So, now the question is how to see that what should be the decision, whether to go for machine P plus Q, where Q will be coming after 5 years, or we should now go with machine R, so that you can use the machine R from today itself. Now, we see that the life of these two altogether is 20 years and the life of this is 15 years. So, if we take the study period as 15 years, it means 5 years of this machine will be unutilized. So, in that case we have to find the implied salvage value of this machine after 10 years. Now, since the two machines are having different lives and machine Q is used subsequent to machine P, the present worth basis of comparison looks better, where you can find the present worth of machine P plus Q at present and also present worth for this, because it has anyway 15 years of life, and then you can also find the implied salvage value. So, on the basis of present worth you can compare whether the replacement is justified, and also you can say that the machine Q, when it will be not used for 5 years, what will it have, the implied salvage value. So, for finding the present worth, what we do is we find the annual equivalent value for this machine. Now, we have basically we have 0 to 20. So, up to 5 years you have machine P, and after that for up to 15 years more 15 years will be machine Q. So, what we do is for this portion you find the annual equivalent value, you take the annual equivalent value of these 10 years and then you find the present worth value. So, if you find the annual equivalent for machine Q, if you find the annual equivalent, it will be 5 lakh multiplied by A by P I 15, so 10 and 15, plus it has two components, one is capital recovery with return part, plus you have annual operating cost, it is given as 30,000. If you look at the factor value of A by P 10 15, so A by P 10 15 comes out to be 0.1315. So it will be 95,750. Now, we have to find the present worth of this system P plus Q. So, present worth will be nothing but 1 lakh is used here. So, it will be 1 lakh plus annual operating cost is 60,000 and it is used for 5 years. So, you have to use 60,000 for 5 years. So, 60,000, then P by A 10.5. The 60,000 which is used every year, its equivalent portion at present time, that will be P by A 10.5. Now, we have 10 years up to 15, we are using 30,000 operating cost, and for this series we have used the annual equivalent value as 95,750. So, first of all, this 95,750 corresponding to this every year we will get the present worth at this time, and this amount will be further converted at 0 time. So, it will be nothing but 95,750, this is A amount. So, we will multiply it with P by A, so that we get the value here. So, P by A 10 and this is your 10 years. So, P by A 10. Now, this amount, for this you have to find the equivalent amount at present time. So, it will be P by F 10.5. So, it will be again multiplied with P by F 10.5. As it is understood that we have the annual values, for these values we are finding the equivalent here and then we are getting here. Now, let us see, it will be 1 lakh plus P by A 10.5. So, P by A 10.5 will be 3.791. Similarly, P by A 10.10, P by A 10.10 is 6.144 and P by F 10.5. So, P by F 10.5 is 0.621. Now, we will multiply this 60,000 multiplied by 3.791. That is 227460 plus 95,750 multiplied by 6.144 multiplied by 0.621. So, that is 365,326. So, this one added to these two quantities. So, this comes out to be 692,786. So, this quantity is the present worth for this plan in which the machine P will be followed by machine Q. Now, let us see if we go for machine R. So, for machine R, using present worth analysis. So, for machine R, since the life is 15 years, we can directly get the present worth value. The present worth it will be, you have the cost 4 lakh plus you have annual operating cost of 45,000 used for 15 years. So, P by A 10, 15. So, if we took at the value P by A 10, 15, it is 7.606. So, 7.606. So, we will add 4 lakh plus 45,000 multiplied by 7.606. So, it comes out to be 742,270. Now, if we go for machine R, the present worth value comes out to be 742,270. So, you see that plan 1 requires less amount of investment initially. So, plan 1 should be preferred. We have taken a study period of 15 years. Now, in this case, we are not using this machine Q for full of its life. So, machine Q is not used for its full life. So, 5 years of life is remaining. So, we should calculate implied salvage value of machine Q. Now, how to calculate the implied salvage value of machine Q? So, machine Q basically we are using it only for 10 years out of its total 15 years. So, its present cost is given as 5 lakh. So, for finding the implied salvage value, suppose the implied salvage value at 10 years of its life is Fn star. In that case, the annual equivalent value for 15-year analysis as well as for 10-year analysis should be equal. So, in that case, your first cost being 5 lakh. So, using its 15 years life, when its salvage value is taken as 0, in that case the annual equivalent value will be A by P 10, 15. Now, its Fn star, that is the implied salvage value at the end of 10 years, for that you will have 5 lakh minus Fn star A by P 10, 10 plus Fn star multiplied by I, that is 0.10. So, this is the equation to find the implied salvage value, which assumes that if the machine is thrown away after 10 years, it has still certain salvage value. So, now A by P 10, 15 as we have calculated, this is 0.1315. and A by P 10 10 is 0.1627. So, basically we have to solve this equation. Then in that case Fn star we can get directly. It will be equal to five lakh into 0.1627 minus 0.1315 divided by 0.1627 minus 0.1. So, it will be nothing but 5 lakh, this is our first equation. So, it will be 5 lakh multiplied by 0.0312 divided by 0.0627. So, it will be 248,803. So, basically what we have seen is you have this implied salvage value which need to be mentioned. Although it does not affect the decision making, and you can say that plan 1 should be preferred. Under the plan 1, where we have taken the 15 years of study period, machine P plus Q should be kept and machine R should not be considered. So, replacement is not suggested. That is P plus Q may be allowed instead of machine R. So, this is how we do the analysis. Now, there is other way also this question can be solved. What we have seen is we have taken the 15 years. Among that 15 years, you have full life of P as 5 years plus 10 years of life of Q, and 5 years of life of Q is not taken into account, whereas you have on the other side machine R has 15 years. Now, if the fate of this machine Q is not known, in that case we have to only go for the 5 years life of machine P. So, in that case the study period has to be taken as only 5 years. So, you have 5 years for machine P and you have 5 years for machine R, but machine R for machine R you have 15 years of time. So, you can go for comparison on the basis of annual equivalent, and on the basis of that we can have the decision whether to go for replacement or not. So, if it is not sure how machine Q will behave, or about its investment plans, it is reasonably correct to assume 5-year study period. So, we will compare on the basis of 5-year, and in that case annual equivalent basis of comparison will be used. In that case also you can get the implied salvage value of machine R, because its life is 15 years and we are only comparing on the basis of 5 years. So, for machine P, if we take the annual equivalent basis, you will find one lakh multiplied by A by P 55 plus 60,000. So, A by P 55 we can see A by P 55 will be 0.264. So, it will be 26,400 plus 60,000. So, 86,400. Now, if we take for machine R, annual equivalent value for machine R will be 4 lakh A by P 1015 plus 45,000. So, A by P 1015 will be 0.1315. So, it will be 52,600 plus 45,000. So, it will be 97,600. Now, what we see is what we have using 5 years approach, 86,400 is the annual equivalent value for machine P, and for this machine R you have 97,600. So, machine P should be preferred. Replacement machine R is not suggested. We can find in this case also the implied salvage value. We can find implied salvage value of machine R after 5 years of its service. So, we have already find the implied salvage value, and that we can get it, and we can get it by solving 4 lakh will be multiplied with A by P 1015. It will be 4 lakh multiplied by A by P 1015. So, 4 lakh minus Fn star A by P 1010 plus Fn star multiplied by 0.1. So, by solving this equation we can find Fn star. So, this way you analyze the problems of such nature, you have seen that under different cases you have to deal by taking the different study periods and you come at different conclusions. Thank you.